All right, here is your video to go over the AP Classroom problems that were about applications of differential equations, specifically learning about exponential growth. So let's go ahead and get started. I've got the answers already highlighted. So if you got the answer correct, you can always skip ahead. But it says the rate of change of the volume. So rate of change of volume with respect to time. Well, hopefully in calculus, rate of change, you're thinking derivative of volume with respect to time is equal to directly proportional. So remember, that's where we throw in that k. And then it says the square root of the volume. All right, well, looking at that, pretty straightforward. That one's going to be E. So this is kind of like story problems earlier in your math careers where you are translating from the English words into the math sentence. All right, if P of t is the size of a population at time t, which of the following differential equations describes linear growth in the size of the population? Well, P of t would be the layer just above dp dt, right? If we took the antiderivative, this would be the change in P over change in time, which means that time is your input and population is your output. And we're looking for one of these that would represent linear growth. Well, this one is going to come back with some sort of square cubed root, because if you went and solved this one's going to come back with some sort of square root. This one's going to come back with a cubic function based on time. This one's going to come back with a squared function based on time. And this one, if you were to take the antiderivative, you would separate your variables. Take the antiderivative, you would get your population is equal to 200t plus c. So what I meant about these other ones, this would end up being 1 over p dp equals 200. Oh, so this would actually end up being some sort of exponential going on. Sorry, I apologize for that. 200 dt, take the antiderivative, you get the natural log of p equals 200t. Okay, so plus c. So you're looking for which one of these, when I go a layer up, do I end up with linear growth? Another way to think about it is linear growth. Well, linear means a line. Growth would be a positive slope. So which one of these is just a constant positive slope? That's going to be A. All right, question 3. This one actually comes directly from an AP multiple choice old exam, one of their released exams. And it's one that, again, you just got to kind of sort through the story that's being told here. So it says, a rumor spreads amongst a population of n people, so our total population is n, at a rate proportional, so that's where we're going to have our k, to the product, so we're going to have k, we're going to have a product of something, the number of people who have heard the rumor, and the number of people who have not heard the rumor. P denotes the number of people who have heard the rumor. So that means our total population minus P represents all of the people who have not heard the rumor. So thinking about this, P is our variable that's changing. So we want the rate of change of population with respect of people who haven't heard the rumor. I'm going to start over. We want the rate of change of people who have heard the rumor, that's the thing in blue, over time to represent the product of those who have heard and those who have not heard. So that's going to end up being B. So some other ones that are in here just to kind of fool you a little bit. This one we can't take because we don't have a product. This one has nothing depending on P, right? This one you're going to have the time minus the population. That doesn't make any sense. And then this one would be the people who had not heard, the people who had the rumor minus the total number of population. That's not going to be our correct way of thinking. Okay, so that one is a little bit trickier, I admit. But again, pull out your important information and think about what each of those mathematical words means. All right, these next two are ones that are very straightforward in terms of finding the original equation. So this is very much what AP will look like in terms of these questions. So the first thing you want to do, remember, is always separate your variables. So get everything with x's and dx's on one side, everything with y's and dy on the other. Take the antiderivative plus c. You get a point just for writing that plus c. Use your initial condition. Oops. Use your initial condition. So the natural log of 5 equals the tangent of 0 plus c. Well, the tangent of 0 is 0, so c is equal to natural log of 5. You can drop the absolute value bars there because the natural log of positive 5 is just the natural log of 5. And then it says y equals. So I'm going to go back to my 1 over y dy. Oop, sorry, too far. I'm going to go back to my line in red where I have the natural log of y equals the tangent of x plus the natural log of 5. And then remember, to get rid of this natural log, we're going to e both sides. But in this situation, on this side, we'll get this to cancel. On this side, we'll get e to the tangent of x times e to the natural log of 5, right? Because we're taking e with that whole side, and that addition gets broken up with multiplication. So now e and ln cancel out, just like the video from yesterday. And we get 5e to the tangent of x, which was letter choice C. All right, number 5. So again, dy dx starts with sine of x times cosine squared of x. We're going to start by separating our variables. So these two functions that are being multiplied together already were in terms of x. Then I'm going to take the antiderivative. Well, the antiderivative of dy, right, there's just a 1 there, so that's going to be y. This is going to require a u sub. And we want to pick the one that is a function within a function. So u is equal to cosine. Du then is equal to negative sine of x dx. So when I go through to make my adjustment, this will be negative integral u squared du. So now I have y equals negative u cubed over 3 plus c. And then I'm going to replace my u. So I have negative cosine cubed x over 3 plus c. And now I'm ready to use that initial condition. So I know that y is 0 when x is pi over 2. Somebody had asked if they should be using their calculator on these problems. This is the type of thing where with that unit circle, we should know our unit circle values at all of those critical angles. So we get the cosine cubed of pi over 2. Well, the cosine of pi over 2 is 0. And when we cube it, we still get 0. And when we take the opposite of it, we still get 0 divided by 3. So c is equal to 0, which means that y itself is equal to negative cosine cubed x over 3. And then it says we want to know the value when x is 0. So now I'm going to take 0 and sub in. And again, working through unit circle knowledge, the cosine of 0 is 1, cube it is 1, take the opposite, negative 1 over 3 gets us our final answer. Okay? Last one, a puppy. A puppy weighs 2 pounds at birth. So at time 0, we have a weight of 2.0, and 3.5 pounds 2 months later. This is a tiny little puppy. If the weight of the puppy during its first 6 months, which really is just telling us that this model would be valid for the first 6 months of a puppy's life, is increasing at a rate proportional to its weight. So the rate of the puppy is changing at a rate proportional to its own rate. Then how much will the puppy weigh when it is 3 months old? So I want to know what's going on at time 3. So thinking about this, we already know how this is going to integrate. We're going to end up with the weight of the puppy is equal to CE to the KT. And again, this first 6 months thing is just reminding you that exponential growth, that's not how a puppy actually grows for its whole course of its life. So for about the first 6 months, it'll grow. But then remember, exponential ends up being the start of eventually a logistic curve, which relates to what's going on right now with our epidemic. All right, so I'm going to use all of this information. I've got my 2.0 as my initial condition. I then can say 3.5 equals 2e, k is what I would like to find, and t is going to be equal to 2. So in doing this, I'm going to end up with 3.5 divided by 2 equals e to the 2k. I'm going to take the natural log of both sides. So this is actually 7/2 over 2. So this is actually 7/4. Don't be panicked by that. 2k times the natural log of e, which means that k is going to be equal to 1/2 the natural log of 7/4. So when I go back to my original equation, w equals 2e to the 1/2 natural log of 7/4 times t. And I want to plug in 3 for t. So let's go ahead and grab our calculator. We've got 2, not 10. Some people were saying that maybe they had some parenthesis issues on your calculator. Remember, your calculator can store variables if you need it to. And I'll show you how to do that again in just a second. But we've got 1/2 natural log of 7/4 times 3. How big is this puppy at 3 months? 4.63 pounds. So 4.6 is how they've rounded. So again, real quick to show you how to store something in your calculator. Let's say you wanted to store that 1/2 natural log of 7/4. So right now that's our decimal, that's our k, but we don't want to round yet because if we round in the middle, we're going to have rounding error at the end, which is what happened to some of you with the pot of soup question. So you can press store as I'm going to choose k just so we're consistent. So now if I wanted to go back, I could say 2e to the k, and then our t was 3. And I'll get the same answer. All right, hopefully that clears up your questions about AP Classroom. You might want to go back and try the pot of soup question again. The answer in its exact form should have been 33.733. So double check that you can get there on your own. We didn't penalize you for it because this is all just checking in for completion, but we do want you to be prepared for that AP test whenever it may be. All right, we'll be in touch soon. Bye.